Alrighty guys, we are doing dihybrid crosses today, and I'm trying to fix the cam so that it's semi-straight at least. Alright, so you guys have this document in Canvas as well, and I'm going to go through 4 problems with you. 2 of them I'm going to work out longhand, and the last 2 I'm going to show you a shortcut, which will help you out whenever we do our exercises later on in the week. So it says to set up a Punnett square using the following information. Dominant allele for tall plants is a capital D. Recessive allele for dwarf plants is a lowercase d. Dominant allele for purple flowers is a W. Recessive allele for white flowers is a lowercase w. We're crossing a homozygous dominant parent with a homozygous recessive parent. So it's a pretty simple trait or cross. They want us to give the genotypic ratio and the phenotypic ratio. Now, genotypic ratios, when you're doing dihybrid crosses, are extremely, extremely long because there are so many possibilities for genotypes. So normally I just stick with the phenotypic ratio. I'm not going to worry about finding genotypic ratio, and you guys will do the same whenever you're doing your problems, at least for me in my class. So my homozygous dominant parent, that means I'm going to have 2 of the same allele, so we know that they are tall, so they're going to be 2 capital Ds. And they are going to have purple flowers, so 2 capital W's. And they have the homozygous recessive parents, that's 2 little d's, 2 little w's. Usually when I do crosses, I try to make it so that my letters really stand out. Like the d's are good, the w's, I probably would have chosen the letter A or B, something like that, that you can definitely distinguish between a capital and a lowercase. But since this is what this worksheet had, we'll just go with it. So that's what my cross is going to look like. Now, you're probably thinking, okay, put a letter here, and each one across each column will get 1 letter. And that's not actually how it works. You have to look within the parent, and you're going to have 2 letters per column. So you're going to start off taking 1 D, and you're going to mix it with 1 of the W's. In this case, this cross is going to be pretty straightforward, because all the letters are the same. So then this D, it's like factoring. Do you remember how to do the FOIL method in math class, first, outer, inner, last? It's basically what you're doing with the dihybrid cross. So my second one is going to be another capital D, capital W. Then I do my 2 inside ones, which happens to be capital D, capital W, and my 2 last ones, capital D, capital W. And you want to start thinking about how you're going to write things, because you have to squish 4 letters into each one of those boxes now. Going down the side here, I'm going to have 2 letters for each one again. So I'm going to do my 2 that are first, which is lowercase d, lowercase w. My outside, my inside, and my last ones. Now luckily for us, all these are going to be the same. Or at least all the kids are going to be the same. So you bring down that capital D for each one, and then you're going to push over your little d. Bring down your capital W, and you push over the little w's. And you'll do that for each one of these. You always want to have your capital letters first, just like you did when you did monohybrid crosses. I think our next cross will look a little bit different on the inside. And these are just very tedious to do. And they never look that neat because you're fitting so much into one box. My genotypic ratio, they were all heterozygous. So it's kind of like blood typing. If you were to do blood typing genotypes, you just write down what you have. If you wanted to do genotypic ratios, I just would have wrote down that they were all capital D, lowercase d, capital W, lowercase w. But again, I try not to do genotypic ratios because they can get to be extensively long. My phenotypic ratio is what it looks like. In this case, we are assuming that it is complete dominance. So we are going to have all of them are going to be tall and they're all going to have purple flowers. So I have 16 that are tall and purple. So now we're talking about guinea pigs, and we're crossing a heterozygous parent with a heterozygous parent. So for my parent crosses, we're going to have a capital B, lowercase b, capital R, lowercase r. So now my cross across the top, when I write my letters out, it's going to look a little bit different. We're going to use that FOIL method again. So I have my first one, so I'm going to have capital B, capital R. My last one is a capital B, lowercase r. Inside is a lowercase b, capital R, and that's my last one. And it's going to look the same going down the side because it's the same genotype. I have another heterozygous parent. And my boxes on the inside this time will look different. Here's my first one. It's all homozygous dominant. And it can get confusing, so definitely take your time on these ones. And these are all little bees. Capital R, lowercase r, capital R, lowercase r, lowercase r's. The heterozygous ones, they give you like a nice wide variety of all of the possible genotypes that you could have had. Oh, messed up on that one. With the last one being a homozygous recessive. So my phenotypic ratio for this one. We're looking to see how many would have black fur and how many would have rough fur. So we're going to go with the dominant traits first when we do our phenotypic ratio. And again, I'm just going to ignore that genotypic ratio there. So as long as I have one capital letter for each one, they're going to show that dominant trait. So I'm just going to go put a little tick mark by each one that has at least one capital B and one capital R. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we're looking for black fur color and smooth fur. So that would be that one, and this one. 3. Now we're doing white fur that is rough. So here's a white rough, here's white rough, there's white rough. 3, and the last one is white fur, smooth fur. I only have one of those ones that's all recessive. So this 9:3 to 3:1 ratio is really common whenever you have your heterozygous parents. That's what your phenotypic ratio should always look like. And you will see that 9:3 to 3:1 pop up quite often as you're going through and doing dihybrid crosses. So that's how you work one out longhand. And you can continue doing them like that if you want to. It's personal preference as to whether or not you want to use a shortcut. Numbers 3 and 4, I'll show you what that shortcut would look like if you choose to do it. In chickens, long feathers are dominant to short feathers, capital F, and long claws are dominant to short claws, capital C. Determine the probability of a long-feathered, short-clawed bird from this crossover here. So you could go through, you could make 16 squares and do the whole gambit there. Or, to make it a little bit simpler, since we are determining the probability of a certain type of bird here, we know exactly what we're looking for. You can cut those crosses in half. What I mean by that is you're just going to do 2 monohybrid crosses. Everybody likes monohybrid crosses because they are nice and simple. So I'm going to put my F's together, I'm going to put my C's together. So I have from one parent a capital F and a lowercase f. From the other parent I have a capital F and a lowercase f. So long feathers are dominant. We're looking for long feathers. So out of that cross there, I have 3 that are going to have long feathers. So 3 out of 4 will be long. Then I'm going to do my C's. And I have a capital C, lowercase c, and then I have 2 lowercase c's. I'm trying to make those smaller so you can definitely see that one is dominant. I'm looking for a short-clawed bird. Short is going to be the dominant one there, right? No, sorry. Short claws, long claws are dominant to short. So we are looking for the lowercase c's. So I have 2 of those. So I have 2 out of 4 there. So I have 3 out of 4 and 2 out of 4. Now what I'm going to do is I'm going to multiply straight across. So I'm going to take 3 times 2, and I'll get 6. And I'll take 4 times 4, and I'll get 16. So if I were to have done a dihybrid cross, I would have had 16 blocks. So that's where this 16 is coming from. And 6 of those blocks would have been that genotype of having long feathers and short claws. You could probably divide that out if you want to. If you want to simplify things, and in math, they always tell you to simplify. So if I divided that by 2, 3 out of 8. All right, moving on here. Use the same approach from above to determine the probability of a short-feathered, short-clawed bird. So short feathers, if I just look at my cross that I have up here, short feathers would have been a recessive trait, right? Long feathers are dominant to short, so that would have been this one right here. So I had 1 and 4 that had short feathers. Short claws was also a recessive trait, and I had 2 that had short claws. So that would have given me 2 out of 16, which would have been the equivalent of what, 1/8? So 1/8 of my birds would have had the short ones. Okay, so that's it as far as just going through and learning how to do dihybrid crosses. They are tedious and time consuming, but they're not difficult. Just make sure that you really take your time when you're going through it so that you don't make silly little mistakes like what I did up here and accidentally copied over a lowercase r when it should have been a capital R. They're very easy to do because you're mixing so many different letters into one box. All right, tomorrow you guys have another little assignment similar to this. It's going to be a 2-day assignment, and you're going to be working on doing Punnett squares. There's going to be 5 examples that you have to write out so that I know that you know how to do them longhand, and the rest of them you can do shorthand. If you have any questions on that, you can refer back to this video if you need a refresher on anything.